Hello. Hello, everyone. We're about to get started, so if you could all just quickly make your way to your seats, that would be amazing. Normally, I find if I just keep talking for a minute or two, people slowly realize what's going on. Okay, so whilst everyone's just getting settled, boring bit of housekeeping here. But the loos, people ask me every single time, where are the loos? They're through the almost invisible door at the back. So if you go through that gray one, there are a bunch of them in there. And that's probably the only boring bit of housekeeping. I'm Ed, the organizer here. Thank you all for coming. Well, it's great to see such a brilliant turnout today. I'm sure partly that's due to the amazing talks, but also, this meetup has grown from strength to strength. We see regular people coming back, new people every time. It's just great to have so many MLOps enthusiasts now in London. I'll start with a bit of bad news followed by a bit of good news. So the bad news is that one of our speakers, Adelkis, is actually unfortunately ill today. So we're hoping she has a speedy recovery and she'll be back with us next time. The good news is that in her place, my CEO and founder of Selden Technologies has agreed to come and do a sort of AMA on the stage afterwards. So we can talk to him about what it looks like to raise money, found a successful machine learning company. But before that, I'm going to hand over to Jamie, who's going to talk to us about tuning foundational models, and I think very timely given a lot of hype that we've seen in the news over the last few weeks and months. So without further ado, I will hand it over to Jamie. And you are Mike 4?
Not sure. 6.
Okay.
4.
You talk now.
Can everyone hear me?
Can you hear me?
Good?
I can turn it off. Okay, thanks.
Michelangelo's David is one of the most well-known sculptures ever created. Apart from its impressive realism and the fact that it's 17 foot tall, what I find most interesting about David is not where David is now, but where David came from. The statue was meticulously carved from a single block of marble. Sculpting in this way is an interesting deviation from what a lot of people think when they talk about creating works of art, science, or even software products. Usually, we think of novelty as new features, new designs, or new ideas. What's fascinating about David is that it was created by the process of removing material. Removal as a form of creation is the idea that I would like to focus on in this talk. As data scientists and engineers in this room, we often approach problems not as sculptors, but as painters. Starting from a blank canvas, we add elements until we're happy with the final result. But it looks like, at least in certain domains, that this might be coming to an end. The rise of large language models in the field of natural language processing, which I'm going to call NLP going forward, and a similar rise of so-called foundational models in other fields is motivating a new way to solve problems as data scientists and machine learning engineers. Now, what we have at our fingertips is not a blank canvas, but a giant, expensive, and cumbersome block of marble. And it's our jobs to turn it into David. I'm going to continue in this talk by giving a quick introduction to the concept of foundation models, what the term means, and how they differ as a tool from the bottoms-up approach that we're used to in engineering. Then we'll talk a bit about how preparing your models for inference is becoming increasingly important, and it's having previously been an ignored field of research. And finally, I want to talk about our work at Titan, building the chisels and mallets to make your lives as sculptors a bit easier. So foundation models are one of the new buzzwords that gets thrown around a lot these days. But what are they? A foundation model is a single machine learning model that's able to be adapted to solve many downstream problems. They've become the de facto standard for pretty much all NLP benchmarks now, but a similar thing is happening in computer vision, where models trained on data sets like ImageNet or even larger data sets are adapted to downstream tasks and achieve excellent results in doing so. Foundation models get this power because they're trained on a vast amount of data, only once, and typically by a very large tech company like Google or Facebook. This trained model, when it's released, can be used as a backbone then for a downstream task. An example of this might be the BERT family, which was trained initially on all of the English pages on Wikipedia. There are loads of examples of other foundation models. In NLP alone, we have the BERT family of models. We have the now extremely well-known GPT family of models. And on top of these, there are hundreds of pre-trained model variants hosted on places like Hugging Face or Spacey that do all manner of tasks and even in different languages. Now, foundation models are really exciting for a number of reasons. Firstly, they do away with a lot of the sort of difficult dark arts behind data science and machine learning. There's no more slow, costly AutoML solutions, trying of hundreds of thousands of different layer types with different optimizers and different training schemes. And as well as being simpler to use, they just typically perform better. Fine-tuned variants of BERTs, T5s, and GPT models sit atop the leaderboard for pretty much all NLP benchmarks you can think of. So given a challenging natural language understanding task, fine-tuning a BERT model as your first solution is a pretty good benchmark and starting point going forward. But this simplicity comes at a price, literally. These models are huge. The smallest of the BERT models that were originally released by Google come in at around 400 megabytes in size just for the model parameters alone. The largest of the BERT-style models, the Dborin XL variants trained by Microsoft, come in at around 6 gigabytes of models in the model weights. And the largest T5 variants, also trained by Google, which top many of the open source leaderboards, come in at around 80 gigabytes of model parameters alone. Now, this is not so big when compared to something like Palm or GPT, which you see a lot in the news. But compared to decision tree models or small computer vision models, they're absolutely massive and require very different infrastructural considerations. You can't run these models, even in the cheaper inference mode, on any old laptop processor. Even smaller BERTs take some care to run sensibly on CPU devices. Most of these foundation models require some sort of specialist hardware to run at any sensible scale, be that high-end GPUs, TPUs, or similar. But the power of foundation models is also at the heart of their weaknesses. The reason that they're so slow is because your BERT model has the ability to categorize resumes, review contracts, detect spam emails, and some can even do this across multiple languages. But in reality, the thing that you really care about is extremely specific. Maybe you only care about one of these tasks, and you only want a model that does that one thing. In the fine-tuning process that these models typically go through, you reduce the model's ability to do everything else on this list, but this isn't reflected in the runtime performance of the model. We expect that it should be faster if its capabilities go down. So what we want to do is extract the smaller, more specialized models that can perform equally well on your task so that it can run faster in your deployment environment. And this broad field of research is what we call inference optimization. Inference optimization, is a catch-all term for things that you do to a model that don't include training it to reach some suitable performance, but are necessary for your model to be successfully deployed. This might include ways to make the model run faster, make it fit on smaller GPUs, or make it faster to download. Some of these are very general techniques that work. Some of these are very general techniques that work on any model types for all deployment scenarios. Many of you may have heard of knowledge distillation, for example. That works no matter what you're doing. Others are very specific. Runtime engines like TensorRT or OpenVINO are specific to hardware families and closely linked to your deployment environment. Inference optimization is particularly important when developing, starting from a large foundation model. This is one of the few dials that you're able to turn when you're developing AI applications starting from a foundation model like BERT. So this has all been a bit abstract so far. So let's look at some examples of optimizations that you can perform, and then we'll look at the challenges of using these in practice. So I'm going to look at 3 examples of ways that you might accelerate an NLP transformer for NLP. The first such task is quantization. Quantization is a relatively well-known way to compress and accelerate models, although its ubiquity doesn't really reflect the challenges of actually implementing it. There are dozens of ways to quantize a model, each that have different trade-offs. However, all quantization schemes involve replacing the 32-bit floating point weights of a model with some reduced precision data type, be that an integer type or a floating point or a 16-bit floating point. But for transformers in particular, this is famously quite difficult. There are even more complicated ways around this, like only quantizing the weights, for example. But doing so often requires you writing your own CUDA kernels from scratch and add tons of complexity to your project. Another well-known way to achieve speedups with transformer models is graph compilation. Transformer models have very similar patterns of operations that run through during inference time. They maybe have a large linear layer followed by element-wise activations like ReLU or normalizations like layer norms. We can create custom fused kernels that execute something like matrix multiplication, an addition, and a ReLU all in a single kernel execution. This avoids costly reads and writes from memory, so it's a useful way of accelerating models. This is a process that's thankfully done for you in runtime frameworks like TensorRT, faster transformers, or the Intel extension for transformers. The final method that I'd like to talk about is early exiting. Early exiting involves setting up ramps after each transformer layer and calculating on the fly a metric of the certainty of the model outputs if it were to be classified after that layer. The rationale goes that easy examples can shortcut through the model, and you only perform a small fraction of the computation if you don't need it. This has been utilized by Google in some of their inferencing models, and this work in particular touches a lot of interesting areas, like model interpretability and calibration. Some teams are looking at these early exited models to try and work out the thought process of NLP models, and well-calibrated models can route these examples more effectively. So apologies if that was a bit technical, but what I really wanted to get across was if there's all these methods that we can use to accelerate transformers, what's the catch here? Why are all these models still so difficult to deploy, and why are we not seeing these things run on mobile phones already? So nothing on this list sounded too difficult to implement. So why do we not see more of these techniques in the wild? Well, so I chose these examples a bit deliberately, because actually these 3 techniques are completely mutually exclusive from one another. If you're using something like TensorRT for graph compilation, then you won't have available to you one of the examples like weight-only quantization, and you won't have out-of-the-box access to the features needed to implement early exiting. You can create a lot of this infrastructure yourself, but this is a serious undertaking. And it's something that you might have to do from scratch for each transformer-based project that you're working on. There's no guarantee that these 3 methods combined is the correct one for your problem either. All this is just unnecessary cognitive burden that data scientists and ML engineers have to go through when they're working on transformer problems. It slows down development, and more often than not, it just results in overly slow and expensive models being put into production. The benefits of getting this right are massive, as we're going to see shortly. But the field right now is too young and too scattered to do this reliably. And that's what we're trying to fix at Titan. At Titan, what we're trying to build is automated inference optimization pipelines. For example, when we first met Ed, actually, at one of these events a few months ago, and we told him what we did, he put it quite succinctly that, oh, you guys are the ones who put distill in front of models. And while this is a good description of what we're trying to do, we want to create smaller, cheaper, well-optimized variants of NLP models. There are some important differences between what we offer and what something like Hugging Face's Distillbot offers or similar. Firstly, we don't create small general-purpose models that are just pre-trained differently. We don't view this as an effective route to creating small models. Whenever you create a resource-efficient models, you have to give something up. What we do is we start with your trained model and a small fine-tuning data set that you've already used, and maybe a description of your desired deployment environment. For example, if it has to run on an Intel CPU or an NVIDIA GPU, or something similar, if it has to be deployed locally, if it requires real-time inference, that sort of thing. Then we go about creating a smaller model specifically designed for that environment and for that problem case. In this way, we're often able to create far smaller models than we're given, which perform extremely highly compared to similar resource-efficient models available on the market. These small models and optimization pipelines might include all the optimizations that we saw earlier, or none of them, depending on the inputs, and that's worked out on the fly. So let's walk through an example of this sort of pipeline. Here we're looking at an example project that the Titan team worked on. This is an NLP product designed to search through a company's communication documents, like Slack messages, Google Docs, etc. The goal was to classify them and then make them searchable in natural language. They went about this the old school way, which is old school now that ChatGPT exists, which was building on top of open source BERT family models because they didn't want to API into OpenAI or similar. Using open source tools, they built a prototype in no time. They had really good performance and they got great feedback from their users. The problem wasn't in the data science, it was in the infrastructure. The model that they created was far too slow to run in real time. Since they were using a larger variant of BERT, they found that the only hardware that achieved their latency constraints was far too expensive for mass deployment to multiple end users. They tried training smaller models, and they were using some of the graph compilation techniques I spoke about earlier, like using Onyx runtime, but nothing fell in a favorable part of that cost to performance to latency landscape. We then applied a simple Titan pipeline to their model and data set. Firstly, we distilled the model into a smaller variant of BERT. We then applied structured pruning, which we're going to see a bit more about later. And we put the resulting model through the TensorRT runtime, targeting a T4 GPU in mixed precision. All in all, we made the model about 14 times smaller, if you include the mixed precision, and it ran about 10 times faster on the original hardware. This was fast enough to migrate to a smaller, cheaper GPU and stay well within their latency constraints. After migrating to the cheaper GPU instance, the cost of running the search and answer system decreased by 96%, suddenly making it economical to run this setup in production. This combination of multiple techniques was the difference between the product not being deployed and being deployable at scale. And the ease of this pipeline abstraction meant this could be done in a matter of hours rather than the weeks or months that it might have taken even an experienced team to get this job done themselves. So, as I said, I'd like to dive a bit deeper into the pruning scheme that we used. Pruning, broadly, is a technique common now in deep learning where you remove parts of the weights in order to make the model run faster. And you try and do it in such a way that it doesn't destroy performance. This is a structured pruning variant, meaning that the weights are removed in such a way that we try to make it faster to run on GPUs. This Titan pruning process is an in-house procedure we developed that's really effective at producing resource-efficient models. If you've seen these papers, it works in a similar way to like the CoFi or ZipLM papers, but that's not really that important. What we do is we identify the least important structures in a fine-tuned transformer, like a BERT model or a GPT model. We remove them and we train them again from scratch and do this many times over. You can see that this pruning scheme produces significantly better models than open source models like the StillBERT, and it's even better than MiniLM, which is a really tough to beat resource-efficient benchmark. We also show results here from a previous implementation of DynaBERT, which used to be a state-of-the-art way of compressing BERTs that we used internally until recently. What I really want to stress here is not the results, but it's that we can create these resource-efficient models in a fraction of the time and cost that it takes to produce like a MiniLM like Microsoft did or DistillBERT like Hugging Face did. All we needed was a tiny fine-tuning data set needed to match the performance of these massively pre-trained models that have also been fine-tuned. And for new models and emerging variants like T5s that don't have good distilled models available, or for low resource languages, or for specific models like medical or financial BERTs, this sort of pruning is one of the only ways to efficiently get resource-efficient inference. These foundation models, in NLP in particular, present a really exciting opportunity for developers and ML engineers. They're a relatively simple way of achieving remarkably good performance for a wide range of NLP tasks. But it doesn't come for free. If we want to make use of this powerful new resource, we need powerful new tools. Tools that make foundation models run at the right speeds, at the right costs, and on the right hardwares. These tools previously have existed in papers and poorly maintained GitHub repos, but have otherwise been off limits to teams bringing valuable products on top of these models. We're trying to open up these tools to developers with the Titan platform. If you're working on NLP problems using Hugging Face, then sign up here on the Titan waitlist, and we can get you started using the Titan pipelines in your own project. And if this work actually sounds interesting and you're passionate about building software or researching ways to make NLP models run faster, then send us an application because we're hiring. And come work with us so that we can help carve a few more Davids from these blocks of marble.
Amazing. Yeah, thank you, Jamie. Really, really interesting talk. What we'll do is we'll do questions in the room. If you're watching online, put your question in the chat and I'll come to those in a second. Is anyone got questions? Don't be shy. Okay, one here. Yeah, you have to speak.
Great talk. I was just wondering if you go back to the slides with the results. I know you said you didn't want to focus on them. I was just, could you maybe just talk through which was the one that was your thing that was the improvement versus
Purple is ours. Purple is ours. Blue is Hugging Face's Distilbert. Red is MiniLM, which is, I think, the go-to for a lot of resource-efficient tasks in natural language processing. The other two was our old implementation of a previous state-of-the-art way of compressing models.
Right, and then so you've got the purple. So for the other ones, they've got a particular number of parameters. For the purple one, you've tested it at various numbers of parameters. And so the thing for us to focus on is the good performance, even when you go down to a much smaller number of parameters.
Yes, yeah. The basic idea is like at a sort of fixed resource, you want to compare like maybe a slice. So this is the same resource roughly. So these will be a similar cost to run, similar latency, and higher is better. And so we only plot the sort of Pareto front of the Minerva process is what we call it, and the same Pareto front of the old process. And you can see there's like a Pareto improvement. So at pretty much every resource level, we get a better performance than we could using open source models or our own previous library.
Great, thanks very much.
Hi, thanks for the great talk. So you mentioned that you're using in this Minerva process an iterative scheme to wind down one of these large models. So if you did want to, if you were using MiniLM or something like that, and you did want to go back to BERT and then come up with a smaller model, what would be the prerequisites that you actually need to do this iterative process? Do you need well-labeled data in large numbers? Do you need a very well-defined problem? What is it that you actually need?
No, so the remarkable thing is that these lines, or this purple line, was produced only with the original model, which was a base Electra model, and the fine-tuning data set. So on the left, it was Squad V2, which is a well-known question-answering data set, and on the right is QQP, which is a text classification data set. So all that we need, kind of as I've shown here, is the original model, preferably fine-tuned on the data set you care about, and then the fine-tuning data set. And what we do is we iterate over the fine-tuning data set. So we fine-tune once, then prune, fine-tune again, prune, then fine-tune again. So that's all that we need. We don't need sort of a big, expensive pre-training data set. And the really nice thing I think about it is that that data set can even be unlabeled. If you have a bunch of labeled data that's fine-tuned, that your model's been fine-tuned on, and you have a huge amount of unlabeled data, that can also go in and that will improve the results. So it doesn't even need a large amount of labeled data to work.
You mentioned that it's hardware dependent, right? A lot of the optimizations. Do you end up in a kind of chicken and egg scenario where you want to optimize a model, but you don't know how much you can optimize it because you don't know what infrastructure you can run it on? And then, do you see what I mean, right? Until you know exactly how small you can make it on that type of GPU, for example, you don't know whether you're going to fit it on or not.
Yeah, it is a bit chicken and egg. I mean, that's what we think we're doing. That's what part of the value that we think we can bring at Titan is that if we can benchmark these pipelines on a whole range of hardware like GPUs and CPUs, then we can give you a good starting point, a good first guess. This process tends to work well when you're targeting CPUs. A lot of attempts at this sort of work, make things modular. So you say, well, I want to apply this process, then apply this process. And that's when you can get stuck in this point of like, oh, I don't know what to apply next that will actually work for my hardware. There's really complex dependency graphs. So we try to handle all that for you, just give you an end-to-end process, model in Intel CPU optimized model out, and minimize that choice making along the way, because it's too much burden. And so we try to make those decisions in advance of what's the right things for what hardware.
So which type of optimization technique are you using? And is it like a variable optimization, or is it, because I understand you're optimizing iteratively, so does your time step vary, or do you have a fixed discrete time step?
What do you mean by timestamp, sorry?
So in an optimization problem, you're going to, each time you'll make a change, right, to your model.
Mm-hmm.
And then you can think of the time step as the amount of change you're making.
Mm-hmm.
So say, for example, if you want to, in an optimization problem, usually if you want to start off by optimizing a problem quite quickly, if you're quite far from your ideal model, then you'd have quite significant and quite sudden steps until you start to reach closer to your sort of like local or global minimum. And then maybe at that point you can switch to like a gradient descent based model. But this is just more like specific to deep learning. So I'm curious if like there's a similar sort of architecture in this case where that you have that varying time step. Yeah,
so the closest thing maybe to a timestamp in this is the gap, I guess, between each model. Maybe I can describe the process a bit, is that you remove some of the parameters from a model, and then we refine tune that model from that new starting point. And each dot on that curve is one model that's had some parameters removed and it's been refine tuned. That fine tuning process, that's also called optimization. So there's a bit of an overloading of terms here. That fine tuning process looks like completely standard NLP model fine tuning. And so that's just like gradient descent with some fancy gradient descent like Adam, is what's happening at every step. But the amount of training at each point is fixed. So there's no fancy search as we get lower and lower. It all just looks like completely normal model fine tuning.
How long does it take to run this process?
This process, it depends on the data set and how low you want to go. So for example, if you wanted to do this, which was 10 iterations, the model gets smaller and smaller each iteration, so each one happens faster and faster. So let's say producing this whole curve is something like 5 times the fine-tuning cost of the model. So if that was a couple hours, like it is on Squad, it's a few hours, then it'll be 5 times that, so 2 hours to 10 hours. If you didn't care to go as low and you only wanted 2 or 3 optimization steps, it would take maybe 1.5 times as long, or 2 times as long, something like that.
Any more questions in the room? Yep, cool.
So my question is, if it's that hard to get it right, like, is it like sometimes that you get like maybe like not a desirable result? Like maybe you run like, let's say those 10 iterations, and after the iterations, like the model is not performing like up to the standard that it should be, because it, like, as you mentioned in your presentation, it's so hard to get it right. Like those cases happen that you have to kind of go back and circle like a lot of times. That is like piling up the time that you ended up spending into developing like the last product.
Mm-hmm. Yeah, well, there's sort of 2 ways that this process that I've talked about today is hard. You're right that there are challenges in this process as well. Like even within like a single process, there are challenges. As for whether this can go wrong, it can definitely go wrong. And sometimes your performance can implode. The kind of interesting thing is that you have these checkpoints you can rewind back to. So for example, if you like the performance here, and then the next one you don't like the performance, you can rewind back to something you liked and restart the process there. And that would take it a bit longer, but we typically don't have to do that. But the other difficulty is in like this part. So when I spoke about these 3 ways of optimizing, these are completely orthogonal ways that are mutually exclusive to one another within the tools that you can use to implement them. By which I mean, if you wanted to apply all 3, and what I showed before was just one of these, was just one such method, you would be completely unable to without building a lot of the infrastructure yourself. So you're right, it's difficult within tasks like pruning, like quantization. And it's even harder when you want to stack them on top of each other because you require tools to interact that were not designed to interact. And so that's part of this pipeline process like we built, like I outlined before, was we produced, we put several of these methods on top of one another, made them all work together, and then got really big savings as a result.
Cool. What we'll do is we'll just wrap up there. And if you have other questions for Jamie, because I know there are tons of things people want to ask, you can find them in the break or afterwards. We'll have some networking time as well. Just before we stop, though, another big round of applause for Jamie. Thank you. So what we'll do, we'll just take a quick 5 or 10 minute break while we get set up for the next speaker. If there are drinks or any snacks left, do go and grab one if you're hungry, and we'll see you back here in a second. Okay. Right, everyone, if I can have your attention again, please. Just as everyone settles down, a couple of quick things to announce. The first, hang on, I have to check this. This is the date of our next meetup, which I have locked in now, but I'm just going to have to check in my diary. May the 16th. So if you're not doing anything on May the 16th, you are now, because the next MLOps London will be happening then. So yeah, look out for it on the meetup. I'll publish it in the next couple of days or so. The second thing to mention is that I'm always looking for new speakers with exciting talks like you saw from Jamie and you've seen from speakers before. So if you have something cool to talk about, it doesn't necessarily have to be something groundbreaking or state-of-the-art research. Really anything. It could be a personal project you've built that you think's cool, that uses a bit of machine learning, a cool thing that you struggled with when you were deploying something. All of those are really interesting tales. The more personal, the better. So yeah, come and chat to me afterwards, or there's actually a request form you can submit on the meetup group, which you'll be able to find too. So I think that's pretty much it. May the 16th, that's the date you're remembering. And what I'd like to do now is to introduce Alex Housley to the stage, who's going to come and talk to us about building ML startups.
Is it working?
Yeah, you're good.
Is that good? Okay, good.
Okay, right. So as I mentioned, unfortunately, Adelkis wasn't able to be here today. Alex very kindly stepped up very last minute. I asked him yesterday, and he said, "Yeah, that's fine. I'll drop all my evening plans." He wanted to come and chat to you guys anyway. So be nice to him afterwards, please.
I have to apologise for taking up the time this evening, but I hope we can make it worthwhile. Great to see such a full house here as well. It's a fantastic event you've been organising, Ed.
Yeah, so what I thought we'd do is I'll ask Alex just a few questions, kind of, I guess, interview style, right, to give a bit of background about what Alex has been through building Seldon as a company. And then I'll open it up to people in the audience. I know there are a mix of people from massive enterprises to people who are just starting out on your own venture, building your own company. And there's a lot of interesting stuff that you might be able to get from Alex today. So I guess the first thing is if you can tell us a little bit about your background and what inspired you to start Seldon as a machine learning company.
Okay, so I'll try and briefly cover my background. So I've actually always been building things my entire career. When I was at university, I built a Wi-Fi hotspot locator. And this was in 2003. And that became a data business in the end, so licensing Wi-Fi data to points of interest companies. And I was running that basically like one-man band. I was pulling in data from various sources, maintaining large SQL queries to aggregate and bring that data together, and then go out, build the website, and then license the data to people. So in the end, after a few years running that, exited to a location-based service, which was had a very powerful recommendation engine at its core, which I think was way ahead of its time. And I was really interested in recommendation, actually, because after building this Wi-Fi data for a database for a few years, it went from a service which was just helping you to get connected with the sort of in very few areas which had connectivity, and then suddenly we had 3G and iPhones and smartphones that you could get connected anywhere. And so that is really what led to my interest in recommendation, just as a general concept, which is how I got involved in this location-based service. And so there was a big pivot towards providing a recommendation engine for other businesses to consume. And I think that was really kind of a trial by fire, because we went from a effectively struggling B2C consumer app with tens of thousands of users to suddenly plugging into newspaper groups that had tens of millions of readers, and we had to satisfy SLAs, response times and uptimes, and handle things like breaking news. So we actually did incredibly well, and I'll give a lot of credit to our CTO of that company, Clive Cox, who actually is CTO of Selden today. So I think that's one thing to take away, just having a great co-founder and someone that can if you're not on the tech as much on the tech side, that is invaluable, right? And I think I'd hope you would agree the other way around. But what we learned through that recommendation engine is really that building the core infrastructure was extremely challenging. So we had a suite of different algorithms we built and used from various libraries for building training models and generating recommendations. But it was extremely hard to scale in that period between 2011 and 2014, when we didn't have the luxuries of cloud native Kubernetes, elastic compute that we have today, and APIs effectively on tap. That obviously we know what we can do today with LLMs and ChatGPT. It's a completely different world. But saw there was a huge amount of interest in building in machine learning broadly. And in 2014, really there was kind of two routes that we could take. One of them actually was effectively an acqui-hire, to sell the company. And the other option, which was a lot more adventurous, was effectively to recapitalize, set up a new company, recapitalize, bring what we could over into the new co, and then set about effectively open sourcing and creating an open source machine learning platform, which had a more general purpose across the broad range of use cases that people were talking about. Even we were hearing firsthand when speaking to corp dev teams and that kind of thing. So it was a struggle, and around that time we had, very unfortunately had to reduce from a team of 12 or so to back to a team of about 4, and set on this new direction, take massive pay cuts, even though it wasn't that high actually at the time, but still, it was a bit of a struggle in that first couple of years. But I think the general vision was that we saw machine learning was going to be a big deal, and the infrastructure was going to be a big challenge. And so the most disruptive thing we could possibly do is to just give that infrastructure away for free at the start.
A really interesting journey. And I think a lot of people, most of you will be familiar from the fact that I normally give a little shout out to Selden at these meetups. They're both my employer and the reason that we have the venue and the food and drink that we have. But most of you are familiar with that MLOps kind of platform side of things, but it's quite nice to hear the kind of story of where it all came from. What were kind of some of the biggest challenges, I guess, both for the business, but also personally for you going through that journey from, as you say, building a startup, kind of reducing size, pivoting, rebuilding the whole thing all over again?
Yeah, so I think in the early days, obviously very limited resource, and at that time, there was only a very small group of experts that really understood what we were talking about, and understood the value in developing a platform on Kubernetes, for example. It was this very early days of even cloud native technology. And so we stopped when we started. We actually were looking to develop a platform that had that was monetized via delivering use cases or models to our customers. So in the early years, we were involved in some quite large scale data science projects, which was the means to the end of actually developing the use cases that could be then reused and productized across a wider set of customers. And I think what we learned through those first couple of years is that the companies that were wanting to solve these problems were in the very early stages of their development. In terms of their they were just trying to sort of do their first sort of skunk works and POCs to sort of prove a concept rather than like rolling out at scale. And there were sort of maybe various sensitivities in the types of use cases that meant, and the sort of the complexity of their specific requirements that meant the models that we were developing were quite fitted to their specific problems. So examples including like an FX market prediction use case that was focusing on a very sort of narrow, like small problem within that around like the prediction on their trading and currency markets, which or stock optimization within a secondhand goods retailer. Like, and so what we found then is that in order to really productionize these use cases, you'd have to basically start to build an entire startup around each of those problems. So, and also when we went through our first phase of fundraising, first round of funding, when people looked at our P&L, we looked like we looked quite heavily like a consulting company because we had a free software, so not much license revenue, and then a lot of consulting revenue, which was the first phase of our next phase, right? So I suppose we didn't get the credit for the software that we built in that early stage, but I think it was sort of forced effectively a big decision and a sort of fork in the road around. Are we going to try to continue to build these vertical use cases, or are we just going to commit to the horizontal and create a platform that we're selling? And so there were a couple of use cases that were very strong candidates to build a whole company around. There was one actually that we were working on with Barclays, who run Rise Here. We were a part of their accelerator in 2016, and we had a use case around credit, predicting credit risk or credit default on credit, so if a loan is likely, predicting if a loan is likely to default before you've given the loan, and so we looked hard at what we built, which was kind of an end-to-end platform. And we really we realized that there's a lot of the development has been happening on the front end of the whole pipeline. So like on the model development, model training side, but then a lot of white space and a lot not much development on the deployment side, and so we basically decided to narrow our focus at that point to just the deployment side. We stripped away all the model training. There was even a recommendation engine from the early days, which had sort of been bolted in. So we had this fairly monolithic sort of, a little bit cumbersome architecture on that side. So we narrowed it all down and focused on deployment. And so the first phase of that was to create a model serving platform, which we called Seldom Core, and it's become one of the standards for ML model serving across frameworks, runs across any framework and any cloud. Again, cloud native and built on top of Kubernetes. And then really, I think that once we launched that, we picked up enough open source usage and a couple of big name customers that we were able to close our first VC round in 2018. Actually, it closed on the 31st of December 2018. So I suppose you could say it was 2019, but that made for a great New Year celebration. So what other challenges, other than that, in terms of just general startups?
Yeah, I was wondering, particularly, personally, I know that you've actually grown out a family during this time, right? And you mentioned having to take pretty hefty pay cuts. You hear stories of people sleeping on sofas and things like that, and hopefully it didn't get that bad, but you never know.
I have slept on the sofa upstairs actually, and I've slept on. I've actually worked through the night at another kind of co-working space in San Francisco when I was on a trip. But no, anyway, like I think especially in the earlier days, in the first, even the first 4 years or so, like there's a significant amount of sacrifice in terms of evenings, weekends, holidays, and yeah, like I got married in 2016, and I think it's just I have to give a lot of credit to my wife for kind of, I suppose, understanding my lifestyle and being accommodating on that. And it's very easy to just go all in, like go fully down the rabbit hole. And I think there are times when that's necessary, but also, I think the art of actually like persevering for longer is to figure out, or to recognize it's like a marathon, not a sprint, and to try and build a more healthy routine that can accommodate that. Yeah, I think in the early days as well, like you're constantly sort of like, I suppose, living a few months away technically from failing, because the runway is short. Until we raised the first VC round, we were doing effectively like rolling angel investments and convertible notes up until a point where we could convert those for the equity round. So I think it takes, like, you have to be like extremely confident in and believe in what we're doing and what you're doing and what the team's doing, and project that into the team. Be transparent of the state of play, but yeah, you have to be pretty confident in success when actually it doesn't on paper look that way until you've actually crossed a threshold. I'm going to give a little example, like when closing seed funding. I think some of you will have been through this as well, but like you reach a certain level of commitment before you start asking people to sort of transfer funds, and to get to the point where, okay, we're there, we're ready to go, and if everyone just decides to bail at that point, it's game over. But then the next day it happens, and then we've crossed that threshold. And as we've grown, I think we've had to my risk tolerance is naturally pretty high, but we've had to adjust that in order to take on the responsibility for more people within the organization. There's now over 60 of us at Selden. We've raised more funding, so it's now $30 million, which following our Series B raise, which there's more at stake, has been invested to get us to this point. So I think one of the big I suppose maybe you're going to ask this question later, but one of the things that has massively helps along the way in the journey is sort of recognizing you go from kind of like wearing lots of different hats and being responsible for everything and getting really into the details of everything, to just like being able to let go of more things and being comfortable with that. I wouldn't just call it delegating, but just setting objectives to smart people that want to focus on certain big problems, and trusting that they will get on with it, and you can check in with them if trust that if there is an issue, they'll come back and you can discuss it. I think the analogy that I like on that is like you start off as like kind of Captain America, and then you sort of then move to like the Avengers. So you bring together your sort of people with various different superpowers to fill out your like VP team, and then eventually, which I don't think I'm there yet, hopefully I'm not there yet, I've become Professor X. So you just kind of like lurk in the background and look at charts and push dials and stuff. But yeah,
I'll give you a second to catch your breath there. Yeah, definitely not Professor X just yet. From judging from the amount you still do for everyone in the company. One of the things you touched on was the funding, and it sounds like getting that initial seed funding is a really big step and really big challenge. Is that the hardest round? Because you've obviously been through that. You've had a Series A, and then it was actually only 2 weeks ago we closed our Series B. So it's an exciting time to be at Selden. How do those differ, right? Have some of them been more or less stressful than others?
I would say actually the seed overall was the toughest actually, because it's just more of a scramble, because you're going from like no external validation really, or very little, and very little, like, I suppose, of a foundation and infrastructure, proof points, and I think we closed the Series A like mid-COVID, so that was co-led by Albion and CIC, and I don't think I met one of them for a brief walk around Hyde Park the week before, I think, the final IC meeting, and then the IC meeting, like, this was like the first time that everyone was taking like a special group meeting, everyone wearing masks, the windows open. This is pre-vaccine, so we didn't quite know, how much of a risk it could be overall. But actually, the 2020, which we closed in 2020, there was a very big spike in interest in AI overall, sort of demand from the market, and we saw that really manifesting in our open source traction, and we were able to convert some customers along the way. So I think overall that was quite a good market for us. The Series B was a bad market overall, and I think anyone that's been raising overall, I think will find that this has been extremely tough. And many investors have just not been investing for periods of time. They've just closed the book, and then I think many of them are reopening it now, but a lot of it is like the timing. If you go out in that 3 or 4 month window when they're just reassessing the state of the market and seeing what, waiting and seeing what happens, then that can be challenging. But for us, I think it's building relationships over time. I think is a critical thing. And the lead investor for our Series B, Brightpixel, we got to know them over a year, and they've taken a significant interest in what we were doing, tracking our progress along the way, even though it was like still maybe outside of or it took a lot more justification than it would have done 9 months prior. We were able to come back after the summer. We all had a little break over the summer because we thought no one's going to be doing any fun term sheets in midsummer after that, and we're able to get things done, at least to get commitment, but then there's increased diligence. I think due diligence in this phase, people want to be extra sure, whereas back in 21, depends on the investor, but there was often a very little amount of diligence and process going into even some of the larger rounds. And so I'm obviously delighted that we managed to get it over the line. And I think if there's people out here like in the audience raising, I definitely would say that now is a great time to be raising seed and to be starting companies, because I think we were lucky to an extent. I won't take credit for it fully, but I think we didn't quite get ahead of ourselves when it came to either raising a round that was, I'd say, too big a valuation that we would then be having to make a big down round, and there's can be kind of like cultural and other consequences of this, because the later stages are have been impacted more, and there's been more significant layoffs across other scale-ups as well. Ones that have been unicorn valuations or multi-unicorn valuations, taking a pretty big hit. But the interest, I think, is still there in the seed stage, pre-seed. Actually, one of our earlier investors, Playfair, I'll give them a little shout out. They've just announced a $70 million pre-seed fund, for example. Even today, I just saw that. And especially in this space, like I think AI is hotter than it actually has ever been. I think, from my perspective. It's fairly ironic, I think, that the ChatGPT, I think, was announced a week, I think, after we signed the term sheet. So we couldn't really ride that wave fully, but I think it helped us to, maybe get through diligence and when people are deciding, is this the right place for us to be? Yeah, and I think MLOps is extremely exciting as well, broadly. And I think, just slightly on tangent, I think this should apply for pretty much everyone here, because of what we're doing is MLOps rather than an applied AI. And what really, I think, excites me and gets me out of bed, and I know a lot of the team as well, is the broad range of problems that your technology can ultimately solve. And it really blows my mind, things which I wouldn't dream that people would be using it for at the start, are coming up with new use cases. So, for example, we're deployed across various drug discovery platforms now, and big companies like Johnson & Johnson and Exscientia. Use cases across manufacturing, companies like Audi, for example. Fraud detection use cases across various insurance companies. So I'm sure the same thing will apply for the folks here that are building MLOps companies. And yeah.
Yeah, I thought I agree with that. Actually, it's definitely one of the cool things. We get to do a bit of everything, and I spent some time with one of our customers who are a car manufacturer, and they've got running things in the production line to test the quality of the engines as they're being built and things like that. They're doing all sorts of cool use cases that I would never have even thought of. You applying ML to. That's really cool. I thought I give people in the audience a chance to ask any questions. Has anyone got one? There we go. Here first, and then work my way back.
Hi, Alex. Yeah, good to see you again.
Hey, Peter.
Yeah. So how do you guys manage to differentiate yourselves from a SageMaker and Vertex by the big guys, the big cloud providers? How do you differentiate? Yeah.
That's a good question. So I think one of the primary things that from the start with Selden is we're an open core platform, and we're platform agnostic. So the two examples we gave there are specific cloud vendors, right? And so we're seeing there are certain categories of companies that will want to just go all in on one cloud, but we're seeing there's more lock-in in that case. And we've been focusing on the on the deployment side, but enabling that in a cloud native way across multiple clouds. And so quite often when people are making their build versus buy decision, or even just their infrastructure plans, sometimes they'll go. One of the big decisions is whether we go from with an all-in-one platform or best of breed. And for the best of breed, end users and companies that make that choice, Selden fits in really well with the other adjacent tools that sit within their stack. And then the most recent releases of Deploy and Core focus on this theme of data centricity, which really isn't sort of at the forefront of other model serving platforms and deployment platforms. So the concept of the biggest improvements you can make to the model performance in terms of the outputs, it can be done by improving data quality rather than just sort of chipping away at the algorithm. So we've been sort of building a really sort of useful feedback loop, I suppose, within the system that gives more actionable insights to the data engineers and the data science team.
Congratulations on the round. What are the plans for the Series B?
So we just crossed quite a big milestone with sort of releasing our Deploy V2 or Deploy Advanced, which is the second generation of our enterprise product. That incorporates the first step along that data centricity vision, which is we're sort of building upon as we throughout the year. So there's a fair amount of product development, and there's even some really exciting discussions happening right now around things like LLMs, for example, which I can't reveal too much right now because they're not fully baked, but there's some really exciting there's developments overall. We've gone through from a kind of a product market fit phase and hitting that first phase of like product market fit to go to market. And we were able to justify at Series B, which is a little bit more, proving that go-to-market engine works, and then ultimately committing to scaling that at a certain multiple year on year. So it's about us finding the balance between product development and continuing that innovation both in the open source and the commercial product, and building out the sort of scalable go-to-market engine. So we have already like the pieces in place there from starting with DevRel and the community, which is obviously a very big part of open source. But then, and actually 80% of our customers start in the open source community. And then, building upon that with our marketing team and BDR team, which actually sits with marketing, and then qualifying through to kind of enterprise account execs that actually really they obviously lead the deals, but I think the people that actually ultimately win the deals are the solutions engineers who are able to prove that the product works for the customer within the POVs. So there's a lot of collaboration that's required across that. And through this phase, we're making more measured and targeted investments in sort of growing each of these teams, and making a few more specific investments in areas where there's a few gaps that maybe maybe we could have more specialized focus, for example.
I'm glad you asked as well, because you may have noticed there are little cards on your seats. We are hiring as well. So if you're interested in joining us or titanML, Titan AI, not ML, isn't it? titanML, they're ML now. Then hit us up. You get.
Yeah, thanks for the talk. It was really, really interesting. Maybe you could speak to, because you're like open source with your core, could you maybe, are there challenges of bringing people to become paying customers, given that you already give so much away for free?
Yeah, it's one, I think really realistically always one of the top 3 topics for Selden internally with our board. And I think we started off by basically going open source by default with basically everything. And I think that was actually a reasonable strategy for the earliest stages to gain enough more kind of viral traction, I suppose, organic traction through maybe giving away more than what your larger competitors would feel comfortable doing. But then at some point we need to start demonstrating how we can convert that into a scalable commercial engine. So we developed an open core strategy, which does have a substantial and what we think is an industry leading core, and we do actually set ourselves the objective as being the best in the market at model serving at the core. So it's not a limited piece of software, but we have to define sort of certain problems that overlay that matter to our customers. And actually the main categories of functionality that I sort of generally put things into for Selden at least, but you may define others for other companies, are around collaboration, policy, and governance. And these are all 3 very big pain points within organizations that the ultimate budget holders will care about. And so that's one sort of vector for us. The other one is around, how do we seamlessly integrate across the serving, monitoring, and explainability, and provide a more sort of unified workflow, which I know kind of fits into the collaboration bucket, but it's shortening the time to value. Ultimately, it's what we're trying to enable people to achieve through the enterprise product. And again, it was a very, very long cycle, because within DevOps, and I think this is a general thing, even though we narrowed to focusing on deployment, which is actually from our perspective is the full production lifecycle, including monitoring and explainability, it's a really still a very broad problem to solve, and so it does require, like, I suppose, time and resource to cover the broad range of functionality that people need or willing to pay for in an enterprise product. And maybe that's one of the things that, from an investment perspective, when people are assessing MLOps companies, if they are broad or even not very narrow, it does require a fair amount of investment to get it up to like a enterprise grade. So I think having a narrower focus at this stage, and especially in this market as it's much more mature than obviously when we started, I think things like the titanML, I think it's fantastic just to have a very narrow focus on the inference optimization. It's a very big problem to solve, and if you can save energy costs, by that degree, that's a fantastic business. So that helps.
I was just going to add that basically, if you're going to build an open source company, don't call yourself something like, I don't know, OpenAI, and then become the most closed thing you could ever be. As people don't like that, or I don't anyway. I realize there are tons of questions, and we've been going for a while, so I'll do one more, and then what we'll do is we'll just open this up for networking, and you can come and find Alex afterwards. So by proximity, you get to go.
I'm the lucky one. Yeah. Thank you for sharing the very fascinating entrepreneurial story. And I'm very intrigued by the challenge you mentioning when you pivot from more consultancy company to a platform company. And in the machine learning space, like even nowadays, big scale up like Data IQ, which is in machine learning development platform space, they still go to market leading with the use case. So I'm curious, what were the triggers that made you decide it is the right time to pivot to a more like platform business? I know that from consultancy facing to a platform business, it may require different mindset, different talents, and a different team structure. And what did you do to ensure successful transformation? Thank you.
Yeah, that's a good question.
I'll repeat that very quickly. So the question is around the pivot that Alex made from a kind of almost a consultancy company where they were doing use cases for people to a platform company. What did that entail? That's quite a drastic thing in terms of the workforce, the type of customer you go after, that kind of thing. Have I summarized that well enough?
Yeah. Well, I think first off, when companies get to the size of like Data IQ, for example, or Selden in a couple of years' time, you can start to verticalize again. So you kind of have the enough critical mass in the sort of platform that is the next way to sort of expand the market by tackling specific use cases. I think our challenge was that we were a pre-seed company with about probably around that time 6 to 8 people. In each consulting project we took on would tie up like 1 or 2 people. It is very challenging to sort of unhook from that cycle. I think ultimately we did have a strong platform sort of heritage, I suppose, from our core in terms of like our background in building out recommendation engine. We effectively learned a lot from that process that enabled us to sort of, within about 6 months of launching Selden, release an open source project, which provided some sort of basic end-to-end ML platform, which at that point I think we had like a recommendation endpoint and like what we called a predictive endpoint, which is just like our general purpose like classification. And so that's actually, I think, where our strengths were. And we were recruiting, I think, data scientists to solve these, to work on these consulting projects. And actually what we found, and this may be, the different types of data scientists that care more about applied work or research work. But I think what we found, which I think is quite lucky potentially, is that the types of problems that we had to solve in certain cases were so complex and quite niche skill sets. There's one as I mentioned in the FX trading that we sort of managed to bring on board data scientists that cared deeply about the research side, and they've given the opportunity to sort of let go of the applied cases and working with customer data to achieve a certain, to build a certain model, and to focus more on, in this case, building out concept drift algorithms, for example, and doing research around the next generation of outliers or adversarial robustness. And so it was I think it required, this is where it required investment for us to take that pivot, I think, realistically. So to just do it organically would have taken a lot longer. And so, it required our seed investors, our lead investors were Amadeus, and they believed at the time in that vision to say, okay, you've built enough of a core foundation in the open source that you can pivot the model and let go of this consulting project until you've developed the next phase of the enterprise product. And actually, there's one other thing which we learned much later, which actually I think is quite an actionable thing for anyone with open source projects here, and was that there is a lot of value in the open source project that you're building, and but customers still, when they're deploying in production environments, have they're putting trust in this project that it will stand up, and if there's any issues, they require someone there to support and to help them fix problems. And so this is something you get out of a commercial software license, but you don't get it out of a Apache 2 license or open source licenses, which are effectively to use at your own risk. So you can basically just consider your open source project, or you can take your open source project and then effectively convert it into what we would call a trusted set of binaries, and then put a warranty wrapper around it, and you can sell that as a product separately. So that was actually something we I suppose developed even more recently in the last couple of years, which we found the market very interested in, especially in regulated industries where having an SLA around software and support around software is a must-have. So, yeah, so I hope I answered your question and went around the houses a bit. But
cool. Yeah. No, all good. I think I'm going to try and summarize in a few points there, right? So there was definitely be patient, have a high risk tolerance for sure, be prepared to pivot, and above all else, have a partner who's very tolerant.
And take calculated risks. That's one of our
calculated risks.
Yeah.
Okay.
Okay. Nice. Brilliant. Thanks, everyone.
Huge thanks to Alex Housley. Yeah, quick thanks to everyone for coming, everyone who joined us online. If you want to rewatch any of these talks, you can find it all on the YouTube channel, so do go and subscribe. And then the final reminder is that the next one will be 16th of May. But you're free to mingle in here for as long as we can until they kick us out, basically. So do chat to other people, come ask Alex questions if you didn't get a chance. Yeah, thank you all.